Okay, that's recording. Yeah, let's start. So welcome to the ECON to it review session. My name's Aniket. Uh, I'll be covering chapters 1 to 12 today, going over all the basic concepts. And my aim here is not only to explain everything in terms of graphs and equations, but also like logically and in simple words. Okay, let's start. We start with opportunity cost and budget line. Budget line is just the dark green line you see here, which basically is the set of all possible combinations between two goods that one can buy given a certain amount of income. So let's say I have an income of 100 and a beer costs $10 and a slice of pizza costs $5. So I can buy 5 beers and 10 pizzas with I would spend all my $100. So that's one point on the budget line. When we have multiple points on the budget line and we join all those points, we construct the budget line. And then opportunity cost of the good on the x-axis is just the amount of good on the y-axis I'll have to forgo to get one extra unit of the good on the x-axis. So here the opportunity cost of one slice of pizza would be half a beer. And then we come to production possibility boundary or production possibility curve. It's just a set of possible combinations that an economy can produce between two goods. So any point under this curve in the shaded region is also an attainable combination, but any point outside this curve is an unattainable combination for the economy. And similarly for the budget line, any point outside the budget line, such as point A, is an unattainable combination for a consumer. Okay, let's go through an example. If it takes 1 hour to make a birdhouse and 5 hours to make a dresser, what's the opportunity cost of a birdhouse and a dresser? So for the birdhouse, each birdhouse, if I want to construct an extra birdhouse, I'll have to let go of 1/5 of a dresser because it takes 5 hours to make a dresser. So the opportunity cost of one birdhouse is 1/5 of a dresser. And similarly, for one dresser, the opportunity cost is 5 birdhouses because it takes 5 hours for a dresser. And in 5 hours, I can make 5 birdhouses. So that's the opportunity cost of making an extra dresser. Okay, that was those were like the most technical concepts of chapter 1 and 2. I won't go into detail into chapter 1 and 2 for the other concepts. They're pretty basic and pretty simple. So let's move on to chapter 3. Let's see if I can. Cool. We start with demand, and so demand is the entire relation between quantity demanded and quantity and price. Now there's a very big difference between quantity demanded and demand. So quantity demanded is the actual amount of good or service that a consumer wants to purchase for a certain price. So and demand is that entire relation of all possible price points, and for each of those price points you have a certain amount of quantity demanded. So the entire curve is demand, and quantity demanded is basically the amount of good for each of those price points. Quantity demanded is inversely related to the price of the good. And then we move on to movements versus shifts in the demand curve. And the simple difference is movement along the demand curve. So the curve itself is not shifting, we're just moving along the curve, and that happens due to a change in the price of the good itself. Versus when we talk about a shift, a shift in the demand curve happens when there are changes in factors other than the price of the good itself. So like price of substitutes, price of complementary goods, consumer income, and so on. Yeah, so here, the curve on the left, if we move along the curve, along all these points, that's a movement, and that's because of the change in price of the good itself. However, a shift in the demand curve is because of factors other than the price of the good itself. Okay, let's look at some examples. So let's assume our good is coffee. What happens to the demand curve if the price of tea increases, which is a substitute? And what happens when the price of tea falls? Then what happens to the demand curve if the price of the coffee itself decreases or increases? And then what happens if the consumer income increases or decreases? So in the first case, when the price of tea increases, that means coffee becomes relatively cheaper than tea. So people who were consuming tea might now shift to consuming coffee. So that increases the demand for coffee. And since it's a factor other than the price of coffee, the demand curve shifts to the right. And similarly, when the price of tea falls, the demand curve shifts to the left. In the second case, when the price of the coffee itself decreases, we just move along the demand curve upwards and left. I think that's an error on my part. It should have been the other way around. So when the price of coffee decreases, so look at the graph on the left. So when the price is decreasing, we're moving downwards and towards the right. But when the price of coffee, which is the good itself, increases, we move left and upwards along the demand curve. So the demand curve doesn't shift because it's a change in the price of the good itself, which is coffee. I'm going to make a note of this because I'll have to change this. Okay. And then what happens if the consumer income increases? So when a consumer has more money, now for each of those price points, consumer has a higher purchasing power. Consumer can buy more of that good for the same price points. So in that case, when the income increases, the demand curve shifts to the right. And similarly, when the income decreases, the demand curve shifts to the left. Okay, then we move on to supply. Just like demand, it's the entire relation between, this should be quantity supplied. I'm sorry about all the errors on the slides. Yeah, it's the entire relation between quantity supplied and price. And again, quantity supplied is the amount at each price point that the producer is willing to supply. And quantity supplied is positively related to the price of the good. And the reason for that is, from the viewpoint of the producer, if a product is selling at a higher price in the market, you would want to sell more of that product to get more money. Yeah, so that's the reason why, just logically, quantity supplied is positively sloped. And then similarly, we have movements along the supply curve versus the shift in supply curve. And movement is when there's a change in the price of the good itself, but a shift is when there are changes in other factors. So again, price of other goods, input costs, taxes, etc. Yeah, so here we have a similar graph to what we saw in the case of the demand. Here we're just moving along the points of the supply curve because the price of the good itself is changing. However, when there are any changes in factors other than the price of the good, the supply curve shifts. Okay, here's another example question. It works similarly to how we looked at demand. I'm going to move forward because there are a lot of concepts to cover. And if we have time, we'll come back to the question. But the answers are in the slides. Okay. And then market equilibrium is when quantity demanded is equal to quantity supplied. And that happens when the demand and the supply curve intersect. So now let's assume we know where the point intersects, but we're not at that price point. And let's see what happens and why this is called an equilibrium. So let's say instead of the equilibrium price of 60 here, we were at a price of 100, and in that case, the supply, we have an excess supply basically, and we can't sustain this excess supply, because what would happen is that suppliers would know they have an excess supply, and nobody's willing to buy that excess supply for that price point. So suppliers would start reducing their price, and once the price reduces, we move along the supply curve downwards, and similarly we move downwards along the demand curve, and this happens until we reach the equilibrium point. And similarly, when there's an excess demand, when the price is below the equilibrium, the market forces push the price up along the supply and the demand curve until we reach the equilibrium point. Okay, so let's do a quick example. Let's say the supply and demand functions are as follows. You have a negative slope for demand because it's downward sloping. You have a positive slope for supply because it's upward sloping. And the equilibrium price and quantity, like to find the equilibrium price and quantity, we just equate the two equations. And solving this gives a price of 15. And putting P equals to 15 in both of these equations, you can see the equilibrium quantity demanded and supplied would be equal, because that's the whole point of equilibrium, that quantity demanded equals quantity supplied. Okay, moving on to chapter 4. Here we talk about price elasticity of demand and supply. So price elasticity is basically us trying to measure the responsiveness of the quantity demanded or supplied with respect to a change in the price. So like, let's say the price changes by a certain amount, how sensitive is the demand or the supply to that price change? That's the whole point of understanding this. And in the book, you would have seen a formula like this. This is the same as what's written on the slide. A Q bar and P bar are just the averages of the 2 points we're trying to compare. And it gives a percentage change of the quantity with respect to percentage change in the price. And it similarly in the case of supply. So in the case of demand, the price elasticity numerator would be change in quantity demanded. And in the case of price elasticity of supply, the numerator would be percentage change in the quantity supplied. And when elasticity is less than 1, we usually call it inelastic. And when elasticity is greater than 1, we call it elastic. And when elasticity is exactly equal to 1, we call it unit elastic or unitary elastic. And these are just a few graphs that show different cases of elasticity of demand. So this is perfectly inelastic, because you'll see any change in price doesn't change the quantity demanded. So the quantity demanded remains constant. So here the elasticity is 0 because your numerator would be 0. And even looking at the graph, it just in simple words shows that your demand is not sensitive to any price change at all. Contrary to this, we have a perfectly elastic demand, which is that for a given price point, the demand can change infinitely. So the demand, there is no change in price. So your denominator is 0 now, which gives you infinity. These two cases are just purely for theoretical purposes. And like, it's like technically we don't see that in real life. And then we come to inelastic demand and elastic demand. Inelastic demand has a steeper slope, which is just to say that even for a bigger change in price, the demand doesn't change by that much. So the percentage change in demand is less than the percentage change in price, and that gives you a value less than 1. On the other hand, for elastic demand, we have that a small change in price can actually induce a big change in demand. So the percentage change in demand is more than the percentage change in price, and therefore your numerator is bigger in this case, and you get an elasticity of greater than 1. And this is just a case of your unit elasticity, where the percentage change in price is equal to the percentage change in demand. And another fact to note is that as we move downwards along the demand curve, the elasticity falls. That's just because we are measuring the same amount of change, but for a bigger amount of quantity. Yeah, that's the reason. And similarly for supply, we have the 5 graphs. You have perfectly inelastic, you have perfectly elastic, you have unit elastic, and then you have elastic and inelastic. Same logic as the curves for the elasticity of demand. Okay, yeah, we'll come back to an example if we have time, because there are a lot of concepts to cover. Okay, now what determines elasticity and how can elasticity be affected? So let's talk about demand first. More availability of substitutes usually means higher elasticity. And the reason for that is if for a good, there are multiple substitutes available in the market, then even a small price increase can easily make the consumer substitute for your good for another good, because there are so many substitutes available in the market, and it's very easy for consumer to just go and buy some other good that's substitute. So high number of substitutes means higher elasticity. And in long run, we also have higher elasticity than short run, and that's because in the long run, it's easy for consumers to change their preferences, change their habits, find new substitutes. So in the long run, elasticity is higher for a good compared to the short run elasticity of that good. And then when we come to supply, yeah, it's the same logic. So you have substitutes. If you have more substitutes, you're basically looking at how easy is it for the producers to shift from the production of one good to another. If it's easy for the producers to shift from one good to the other, then your elasticity would be higher. And same logic goes for long run, short run. In the long run, it's easy for the producers to shift to producing other goods than the good itself. So long run also means higher elasticity in the case of supply. Okay, moving on. Give me one sec. Cool. Okay. Now we look at how elasticity reacts with the burden of tax. So usually when the demand is inelastic and the supply is elastic, we say the consumer has a higher burden of tax and the producer has a lower burden of tax, compared to when there's we have elastic demand and inelastic supply. In that case, the producers have a higher burden of tax compared to the customer. So let's look at the graph on the left here. So initially the supply and demand curves were S and D, and there was a tax introduced that shifted the supply curve leftward or upward. It's the same thing. So now this entire tax, the burden of this entire tax is split between the consumer and the supplier. And as we see, so the size of the tax is PC minus PS. So this whole vertical difference, because that's the difference between the two supply curves. And the way we split the burden of tax is we look at the equilibrium price. And so the difference P0 minus PS, this small vertical gap, is the burden that the producer pays. And then this bigger vertical gap is PC minus P0, which is the burden that the consumer has to pay. And similarly, we look here the PC minus P0 gap, which is the burden of the consumer, is smaller than the P0 minus PS gap, which is the burden for the supplier, which is larger in this case. And it's easier to think of, okay, so in simple words, the reason why this happens is, so let's look at the case on the left where we have inelastic demand. So inelastic demand basically means that consumers don't have that much of a power in terms of changing the quantity if the price changes. So inelastic demand means that even if there's a large change in price, the demand for the consumer doesn't really change by that much, right? Because the consumer doesn't have, let's say, a lot of available substitutes in the market, or for like some other reason. So you have an inelastic demand, so you know that the price, a big price change will not induce a similar magnitude of a change in demand. So in that case, what happens is, think of tax as an increase in price, right? So when we know that the consumers won't react that harshly in terms of changing what the demand as a quantity, we can shift more of the burden to the consumers, because we know that they're not going to react drastically in terms of reducing their quantity. And we give the suppliers a smaller burden because we know that the supply is elastic. So the suppliers might react drastically by changing their quantity supplied by a larger amount. So hence, in this case, we have a larger burden to the consumers and a smaller burden to the suppliers. Whereas on the right-hand side, when the demand is elastic, we know that the consumers react drastically, or the change in quantity is higher because the demand is now elastic. That's why we give a smaller burden to the consumers, because we know consumers are more sensitive to price changes. And since supply is inelastic, we know suppliers are not that sensitive to price changes. So we can shift more of the tax burden to the suppliers. Our aim is to make sure that we want to keep the new quantity after the tax close as to the efficient allocation. And we'll see what efficient allocation means when we talk about chapter 12 and efficient allocation. Okay, so I thought this was an important thing in the textbook that might be useful to solve questions in the exam. So let's say you have a given tax T, and the question is asking you what the new equilibrium is and what is going to be the burden of the consumers, what's going to be the burden of the producers, and so on. So let's say you start with the question and you have a given amount of tax, which is the small t, and you were also given the initial equilibrium, let's say P0 and Q0. So these were the two things you were given, the initial equilibrium and the tax. Now the question asks, what's the equilibrium, or like what's the level of the burden that the consumer and the producer have? Now in that case, so instead of having two equations with a common P, now the P changes, right? Here, without the tax, PC and PS are the same. But with the tax, they're different. So we know that the price of the supplier, PS, here, this is just PC minus this gap, right? Which is just the tax. So we know that PS is just PC minus the tax. And that gives you a relation between both the prices. And you have T given. So T is not a variable, it's a given amount. And now you can substitute this into these two equations here. And instead of PS, you input PC minus T. So now you have two equations that you need to equate. And they are in terms of P of C. And when you solve these two equations, you get a value for P of C. Don't worry about all these A, B, C, Ds. They're just constants and slopes in the equation, so it'll be actual numbers, and T would also be an actual number. So you'll get a constant value for P of C. Now we know P of C is just the burden, or just the price at which the consumer functions. So now, in order to calculate the burden for consumer is PC minus P0. This difference between the top two horizontal dotted lines in gray. So that's the burden of the consumer, PC minus P0, and you would be given the initial equilibrium in the question somehow, or like you would have had to calculate it for a part earlier in the question. So it's just the difference between PC minus the initial equilibrium that was there before the tax. That gives you the burden on the consumer. And then the burden on the producer is the initial equilibrium P0 minus PS. And we can already find PS from here because we found PC. So that minus tax gives you PS. And then P0 minus PS would give you the burden for the supplier. So now you have the burden for the consumer and you have the burden for the supplier. So if you see a question on the exam, this is how you approach it. It's not that complicated. Okay. Then we move on to some other forms of elasticity. So income elasticity of demand is, again, we want to see how sensitive the quantity is to certain factors. So price elasticity, we see how sensitive quantity demanded or quantity supplied are to changes in prices. Here we look at changes in income. We divide income effect into three different goods. For normal goods, so like most of the goods in the economy are normal goods. As income increases, we also increase our demand for normal goods. An inferior good, on the other hand, is something for which the income effect works the opposite way. So, for instance, as let's think of a black and white TV. That's the most used example in economics, I guess. So, like for a black and white TV is an inferior good because a normal good for the same category would be like a colored TV. So, once your income increases, you would want to have less of the inferior good and more of the normal good. So that's how the logic works. Then we move on to luxuries and necessities. The more necessary an item is, the less is the income elasticity, and that makes sense. If something is necessary, then your income level won't affect how much of that good you buy by a lot, because it's a necessary item. Versus a luxury item would have a higher income elasticity because having more of an income definitely affects if you want to buy a luxury good or not. Unlike a necessity, which you have to buy irrespective of how expensive a necessity is. Okay, and then we look at cross elasticity of demand, which is basically, again, we want to see how the quantity of our own good changes. So how sensitive is the quantity of our own good? But now we are seeing how sensitive it is to changes in the prices of other goods. And in the case of substitutes, we have a positive cross elasticity, which logically makes sense because if the price of a substitute good, let's say good Y is a substitute good, if the price of the substitute good increases, then people will shift to your own good. So let's say Y is tea again, and X, which is our good, is coffee. So if the price of tea increases, people would also start demanding more tea. So the percentage change in the price of tea is positive. So you get a positive denominator. And the percentage change in the quantity demanded of coffee, which is the numerator, is also positive. So you get a positive value of the cross elasticity. And we work out the opposite logic for complements. If let's say instead of Y being T, let's say Y is sugar. So now they're complementary goods. If the price of sugar increases, then the demand for coffee is going to go down. So you have opposite symbols in numerator and denominator, and hence you have a negative cross elasticity. Okay, let's move on to chapter 5. So price floor is it's confusing because it's above the equilibrium, so it's not literally speaking of floor, but the way it works is, so think of it this way: it's a threshold below which a good can't be sold. So since you can't go below a floor, I guess that's the logic here. A good can't be sold below a price than the price floor, and this usually creates an excess supply, because we saw when we were looking at the market equilibrium, if we sell above the equilibrium price, there's an excess supply. And an example of a price floor could be minimum wage, and in that case, an excess supply would mean unemployment. Similarly, we have price ceiling. Again, in literal terms, it's not a ceiling because it's below the equilibrium, but from a logical perspective, it says it's the maximum price at which a good can be sold, so you can't go above a ceiling. So that's why it's called a price ceiling, because you can't go above it. And this creates an excess demand, similar to what we saw in the market equilibrium graph. And an example would be rent controls. But this can lead to a possibility of black markets. And black markets are basically same good being sold above the price ceiling level. So let's say the price ceiling was set at P1 here. And so in that case, we have an excess demand, right? So there's a smaller supply, but there's a higher demand. However, what can happen is the suppliers can take this supply of Q2 that's available in the economy and sell it at a price P2, because at the price of P2 here, there are willing people who would want to buy exactly the same quantity Q2, right? Because the demand curve is the entire curve, and it's a relation between each of these price points. So at a price point of P2, there are some people who are willing to buy Q2 units, and that's exactly how many units are available from the supply side. And therefore, it's possible that in the black markets, you have this shaded region of profits that are created. So yeah, that there's a potential of black market development when there's price ceiling. Okay, and price ceiling and price floor can lead to market inefficiencies. And what that basically means that it reduces the economic surplus. So economic surplus is, so instead of this small shaded triangle here, think of it on a bigger magnitude. So let's say this entire bigger region on the left was shaded. So that entire thing is the economic surplus when we're functioning on the equilibrium. But the moment we put a price floor or a price ceiling, we limit the quantity at a lower amount. So here, the quantity that would actually be supplied or bought in the market would be Q1. It's always the lower quantity, because if you it doesn't matter if it's demand or supply, it's always the lower quantity of the price intersection. And that's because if you have a higher supply but not a lot of people are willing to buy it, then your economy can't function on that high supply. Similarly, when you have a low supply and a high demand, then you have to function on the low supply, because you can't just suddenly buy more than what's available in the economy. So it's always the lower quantity that we function on. And in both cases, the shaded part is the part of the economic surplus that's not captured anymore, and it's a loss. So that's what we call a deadweight loss. where certain restrictions in the economy cause us to not fully take advantage of the entire economic surplus, and some surplus is left out, and that's what we call a deadweight loss. Okay, let's move on to chapter 6. Now here we are we start talking about consumer theory and how consumers make choices. So marginal utility is, so let's see what utility is. Utility is basically the amount of happiness you get out of consuming a product. So marginal utility is the additional utility you get from consuming one more unit of the product. Yeah, so it's just the additional happiness you get from consuming one more of that good. And the law of diminishing marginal utility says that as you consume more and more of a good or service, the additional utility you keep on getting is lower and lower. So like, let's say I start eating an ice cream, my marginal utility is positive from the first ice cream, but when I have the second one, it's still positive, but I get a lower additional happiness. And then for the third one, I even get a lower additional happiness again, and so on and so forth, until eating the next ice cream would give me a negative utility, so would not make me happy at all, like probably a bad stomachache or something. But yeah, that's the main idea, that continuously consuming more and more units will give you less and less of additional happiness for each of the next good you consume. So you have like a downward sloping marginal utility curve for the same reason, and that's why you have kind of this hill shaped total utility curve, which just goes to show that up until some point, which is like the top of this hill, you have a positive marginal utility. Even though the marginal utility is decreasing, it's still positive. So each additional good still gives you some smaller and smaller amount of positive happiness. So your total utility still keeps on increasing, but at a decreasing rate. So when you reach this maximum, it's the same point at which the marginal utility is zero, because after that, you're going to get negative marginal utility. So you're not getting any happiness, and your total utility starts to fall. Yeah. So that was marginal utility and total utility. And now we move on to utility maximization. So the aim of the consumer is to maximize happiness. And the way that happens is through this condition, where the ratio of the marginal utility respective to that good's price is equal for both of the goods. And it's easier to think in terms of the first point, the first bullet here, rather than the second. You can think of it in both ways, but for me, it's usually the first way that makes more sense. And the reason is that, so let's say this is the condition we have. So the ratios are not equal. Just move px to the denominator here and mu of y to the numerator here. So it's just saying that this ratio, mu over p of x, if you just take this down, is less than mu of y over p of y. So what it's saying that the additional utility I get out of y relative to what I'm paying for that additional good is more for good y. So that means I would consume, that would initiate me to consume more of good y, because it's more beneficial in terms of my utility. And I would do that until this equality sign is restored. Similarly for the opposite case. And the reason is that once this equality is restored, both goods are giving me exactly the same amount of additional utility relative to what I'm paying for those goods. And I have no incentive to consume one good over the other. So that's why this equality exists. And similarly, if we have the greater than or less less than sign the other way, then it's the logic works the opposite way. So in that case, the good X gives me a higher utility relative to what I pay for that good, and I would want to consume more of X until this equality is restored. And the reason we compare the ratios relative to the prices is simply because comparing just the utilities is not enough if one good differs from the other in terms of price. So let's say, like, if good A and good B give me the same marginal utility, but good A is way more expensive, then spending that big amount on good A also takes out some of my happiness. So logically speaking, the price of the good should also impact my happiness. So that's why we take the ratio of the marginal utility respective to what I am paying for that good. Okay, now we come to income and substitution effects. So when we say that quantity demanded is inversely related to price, that whole effect is not just one effect, it's split into two effects. So you have income and substitution effects both contributing to this inverse relationship. And we'll see how these effects vary for different categories of goods. But the substitution effect part is basically change in the quantity that's demanded that results from a change in relative price. So by relative price, I mean prices of comparing to prices of substitutes and complementary goods. So just substitute goods in this case. So that's why it's called substitution effect. So let's say if the price, so our good was coffee. So if price of coffee falls down, the reason why that increases the quantity demanded, and we move downward the demand curve, is because so part of that is substitution effect, and that comes from saying that now since your own product's price has reduced, its relative price to its substitute has also fallen down. So our product is now cheaper relative to its substitutes. So that's one part of the entire effect that leads us to moving down the quantity, the demand curve. The second part of this moving down the demand curve effect comes from the income effect, which is basically related to the purchasing power of a consumer. So if the price of the good itself, so if the price of the coffee falls, now a consumer who buys coffee has more purchasing power with the same amount of income the consumer has. So let's say I have $10, and the coffee, a pack of coffee was initially $10, and now it falls to $5. So with the same amount of $10, I can now buy 2 packs. So that increases my purchasing power. And that's the second part of the effect that allows us to move down the demand curve. So this moving down or up the demand curve is a combination of these two effects. And now we'll see how these effects differ for the 3 categories of goods. So for a normal good, both income and substitution effect work in the same direction. And that's why you have a more elastic curve here, a more flatter curve here, because the income effect and the substitution effect are working in the same direction. But for an inferior good, as we saw, the income elasticity was negative. That means once you have a higher purchasing power, you want less of the inferior good and you want to shift to more normal goods. So here, the substitution effect still works in the positive way, because when we talk about substitutes, we are still talking about the same category. So one inferior good and another inferior good. So substitution effect always works in the same direction for all 3 categories, because you're comparing the same category of goods between 2 goods. But the income effect here works in the opposite direction, as we saw. So you get a steeper curve, and it's still downward sloping because this opposite direction of income effect is not enough to compensate for the substitution effects direction. And that's why you still get a downward sloping curve, but it's steeper than compared to what a normal good has. So this is more inelastic. And a Giffen good is just a special type of inferior good, where the income effect actually outweighs the substitution effect. So it's just a special, call it a subcategory of inferior goods. It's just a good where the opposite direction of income effect outweighs the substitution effect. So you get a positively sloped demand curve. Okay, now let's talk about consumer surplus. Consumer surplus is just the difference between the total value that the consumer places on all units consumed. So let's say on the graph here, the market price is $1. So think of that as P1 here. But for all of these quantities, we have a demand curve, right? So imagine there's a point between all of these bars, and we join all those points, and you get the demand curve, right? So for each of these price points, you would have had a specific quantity, right? But since the market price is fixed at 1, or like the equilibrium is at 1, for all of these quantities, we're still selling at 1, because that's what we get from the equilibrium. So all this additional benefit, this is what the consumer surplus is. Yeah, it's the difference between the value that the consumer is actually placing on the good for all these units. So that's the area of these bars minus the actual price or the payment that they make to purchase that good, which is 1. So the difference is this area. And if you look on the right, it's more clear in terms of the graph, where the orange shaded area is the consumer surplus. Yeah, and we'll get to producer surplus in a bit, but it's the same idea. It's the difference between the value a producer puts on a particular for every quantity minus the value that the producer actually receives from the consumer. So that's the price. So it's basically the difference between the point on the curve minus the equilibrium price for all the points until equilibrium. So all these differences, so think of them as like these different bars, which is more clear here. And similarly for the producer surplus, you'll have like all these different bars here. So yeah, this is when the surplus is maximized, when you're actually functioning on the equilibrium and there's no deadweight loss. This is the actual efficient allocation. Okay, let's go ahead. And just like to see how you might get a question in the exam where they ask what's the change in consumer surplus. So let's say the initial supply and demand were these initial curves without the subsidy. So they intersect at the point 35. So this is the equilibrium right here. And so your consumer surplus would be this dark green triangle, and your producer surplus would be this dark orange triangle initially. And then let's say there was a subsidy, so that shifts the supply curve to the right. Subsidy is the opposite of a tax, so instead of shifting it to the left, it shifts it to the right. And now your new consumer surplus is this whole big of a green triangle with this light green part and this small orange part as well. It's just overlapping. So this now you have a bigger green triangle. So the 25 point till this point till this point, this whole triangle is now your consumer surplus. And this whole, if you can extend this line like below, like this whole triangle is your new producer surplus. So what's the change in consumer surplus? It's just the difference between the areas of the old triangle and the new bigger triangle, which is this black outlined part. So this rectangle plus this small triangle. This trapezium is what the change in consumer surplus is. And it's not hard to calculate. You just split it into two. You calculate the area of the rectangle first, and then you calculate the area of this small triangle. And then you have the change in consumer surplus. Okay, let's move on to chapter 7. I'll have to kind of make it quick. So a production function is just a way of seeing how many units are produced in the economy, and it's a function of the inputs. And the inputs are labor and capital. You can have multiple inputs, but for simplicity, for now, let's say it's a function of labor and capital. There's a difference between economic and accounting profits. Accounting profits don't include implicit costs. That's the only difference between accounting and economic profits. And we have 3 different time periods. We have short run, long run, and very long run. And we'll see how factors vary across all these 3 time periods. Okay. So for short run, total product is just what's totally produced in the economy. Average product is that total product divided by the number of variable factors that were used to produce it. And marginal product is the change in total output when we add one more unit of variable factor. So let's say we hire one more unit of labor. What was that additional labor's contribution to the total product? That's marginal product. And law of diminishing returns just says that at some point, as we add more and more variable factors, we'll initially have increasing returns, but after some point, we'll have diminishing returns. So each additional variable factor would contribute less and less to the total product. So that's the law of diminishing returns. And marginal product always intersects average product at its maximum, and we'll see that in the graph. So yeah, these are just the formulas. Total cost is total fixed plus total variable cost, same for the average. And as we saw, marginal cost is what an additional unit of variable factor brings to the what additional unit of variable additional unit of quantity brings to the total cost. So similar to marginal product, here we have marginal cost, which is what's the additional cost of producing one more unit of the good. And marginal cost always intersects average costs and average variable cost at their minimums. And we'll see all the graphs in a sec. And capacity is just a term for the output where the average total cost is at the minimum. So where the marginal cost intersects the average total cost. Okay, so let's look at the graphs. So first, as we saw, marginal product intersects average product at its maximum, and the reason for that is very simple. So in simple words, when your marginal product is higher than the average product, so whenever your marginal product curve is above average product, that just means that each additional unit of labor is bringing more to the table than what an average labor was bringing earlier. So that each higher addition, so let's say initially the average product was 10 goods per unit of labor. And then when we hire an additional unit of labor, the addition that additional unit brought to the table was 11 units. So that extra 1 unit is now split between all all units of labor, because that's how we calculate average product, right? It's the total product divided by the number of variable factors, which is the units of labor. So that additional 1 unit is now split between all units of labor. So your average product increases. So, and that keeps on happening as long as the addition by each extra unit is more than the average. So as long as the marginal product curve is over the average product curve, the average product keeps on increasing. And that's why the marginal product intersects the average product at the maximum. Now, when it comes to costs, there are two things to notice. Let's look at the cost curves separately. So you have the marginal cost curve, cutting the average variable cost and the average total cost at their minimums. And then you also see that as we increase the output, the average average variable cost is becoming closer and closer to the average total cost. But these two curves never meet. And the reason for that is the difference between the two curves is just the average fixed cost, which is falling and falling and falling and falling, but is never going to be zero. So this gap between the two curves is going to be smaller and smaller, but they're never going to intersect, because average fixed costs are never going to be zero, even though they're going to be smaller and smaller as we increase the output. And two more important things to note are that the maximum of the marginal product intersects with the minimum of the marginal cost, and the maximum of the average product is corresponding to the minimum of the average variable cost. So where MP and AP intersect, that's exactly where the MC and AVC intersect. Okay, let's move on. Okay, let's move on to chapter 8. Now we look at producers in the long run, and the difference between short run and long run is that in short run we had labor as the variable cost, and we had capital. We had labor as a variable factor, and we had capital as the fixed factor. However, in the long run, the producers can change both the level of labor and the level of capital. So both labor and capital become variable factors. However, in the long run, technology is the only thing that's fixed, and that also becomes variable when we talk about the very long run. So let's focus on long run now, and we have both capital and labor as variable inputs. And so similar to how consumers were maximizing their utility by comparing the additional benefit you get with respect to what you paid for it and comparing it between two goods, producers also do the same thing, but with both input factors. So similar to what we had in terms of consumers, we have that the ratio of marginal product of capital to marginal product of labor should be equal to their respective price ratios. And you can just take price of capital and take it down to the left, and take the marginal product of labor and take it to the numerator on the right. And then it's just an equality between the ratio of the factor with respect to the cost of that factor for both of the factors. The reason why we do this is because if there's an inequality, so let's say MP of K over P of K was greater, that means that each additional unit of capital relative to what I'm paying for that additional unit is bringing me more of the product compared to what a unit of labor is with respect to what I pay for that labor. And so that's why I'm going to substitute more towards capital. I would want to have more capital compared to labor, and I would keep on substituting the labor out for capital until I get this equality sign. So the same logic when we talked about customers, but now from the viewpoint of the producers, and instead of goods, we have the two input factors. So the long run average cost curve is basically, okay. Yes, this is being recorded. It'll be posted on the ESA YouTube channel. Okay, cool. Let's move ahead. Perfect. So the long run average cost curve is basically the average cost in the long run, where both of the factors again are variable. And the reason it's defined as the lowest possible cost for producing each level of output is because in the short run, that it was not possible to produce at the lowest cost because we were not able to reach an optimal level between capital and labor because capital was fixed. However, in the long run, when both factors are variable, we know how to optimize the quantity of both factors. So we know how to reach the lowest possible cost by optimizing the quantities of both labor and capital. And that's why the long run average cost curve is just all the points where the cost is minimum. And we'll see. So the long run average cost curve has 3 different parts to it. And we'll see what that looks like in just a sec. Okay, but before that, so another way to look at the long run average cost curve is to think of all the points of the LRAC as the minimum points of the short run average total cost. So let's say the long run is 10 years, for instance. Then for within those 10 years, we individually look at all the short run periods. So you can define short run as whatever you want. Let's say it's 1 year. So you look at the 10 different short run periods within that long run. And then for each of these short run periods, you have a short run average total cost curve. Now, the minimum point of that short run curve for each of these 10 years, if we take that and join them, that's how we get the long run average cost curve. And the idea is again the same, that you always achieve the minimum cost because you can optimize the quantity of both input factors, because both input factors are variable. Okay, now we look at the 3 parts of the long run average cost curve. The first section is where we have decreasing costs. So your costs are falling down. And we saw this is where we get increasing returns because the marginal product is increasing. Similar to what we had here, when your costs are falling down, your marginal product is increasing. So you have increasing returns. So similar logic, you have decreasing returns and you have increasing returns and decreasing costs. Then you have the minimum efficient scale, which is the point at which you attain constant costs and constant returns. So that's why it's flat. And then you have increasing costs and decreasing returns. Again, similar to the logic we had for short-run curves. So when the cost is increasing, your returns are decreasing. So the long run average cost curve can also shift. So let's say there's a rise in factor prices that shifts the long run average cost curve upward, because now all the minimum cost points will move up if there's a change in factor prices. A fall in factor prices, on the other hand, a fall in factor prices or a technological improvement will shift the curve downward, because now the minimum cost points would be even lower than before, because like you had like, let's say the price of one of the factors was reduced. Yeah. Okay, let's move on to chapter 9. One sec. Sorry about that. Now let's look at competitive markets. We start with perfect competition. And the main idea behind perfect competition is that every firm in the market has the same product. So you have homogeneous products. There's perfect information, so every firm knows everything about the market, and there are a lot of small firms, such that each individual firm's decisions cannot affect the industry at all. And then there are no barriers to entry or exit. And we'll see why this leads to the price equating to the average revenue, equating to the marginal revenue. Okay, so now if you look at the two graphs on the right, each individual firm's demand curve is perfectly elastic. Now, this is just a way of showing that no matter how much a firm increases or decreases its quantity, it cannot affect the price of the good in the industry, because each firm is a price taker. It takes the price given to it by the industry, by the set of all the firms. So this is just a technicality to show that each firm's output level decision doesn't really affect the price of the industry. And so that's why we get a price of 3, which is the average revenue and is the marginal revenue, because since the price is fixed, it doesn't matter how many units you produce, the price is going to stay fixed at 3. So your average revenue would be that quantity times 3. And when you divide it by the number of units, you just get the average revenue. Similar to marginal revenue, since the price is fixed in the industry, selling each additional unit would get you 3 no matter what. So marginal revenue is also equal to the price. Now we look at profit maximization. And so first, profits are total revenue minus total costs. And just for terminology, shutdown price is when the point at which the average variable costs are minimum. So the point at which MC intersects AVC, that's the minimum point of the AVC curve. And profits are maximized at marginal revenue equals marginal cost. And the reason for that is very logical. So we have marginal revenue equals price equals AR in this case. So this horizontal line is the marginal revenue. So let's look at the points to the left of Q star. So on all the points to the left of this dotted line, you have the marginal revenue bigger than the marginal cost. So that means that if I produce one more output, it's going to generate more of additional revenue, and it's going to generate me more of an additional cost. So I would want to do that, because then I'm earning a profit, right? For each additional unit, if I receive more than what it costs me, then for that additional unit, I'm earning a profit. So I would want to keep doing that until I have consumed all the profits. But if I go beyond that level, let's look at all the points to the right of this dotted line. The marginal cost is bigger than the marginal revenue. So each additional unit is costing me more to make than what I receive for that when I sell that good. So I have no incentive to go beyond that point, because then I start incurring losses on each additional good. So that's why the point at which the profits are maximized is MR equals to MC. And you'll see that at the point MR equals to MC, the profits are the shaded region. And that's because if it's cost, so the average total cost tells me what it's going to cost me for that quantity. So the quantity is Q star. And for Q star units, the average cost is C. So C times Q star is the total cost I have, right? So we got the total cost part of the profits here. That's C times the average total cost, which is C times Q star, which is the total, which will give me the total cost. That's this big white region below the shaded region. And total revenue right here is just quantity times price, right? So Q star times P. So that's this bigger rectangle. And when I subtract the smaller rectangle from the bigger rectangle, I get the shaded region, which is just quantity times the difference between the price and the cost. Okay, let's move. Supply is just the part of the MC curve that lies above the AVC. So the rising part, so above the AVC. So from this point, the entire MC is just the supply curve, because suppliers would want to supply at a price that are at least covering the marginal cost. So if we this is one of the points on the supply curve for this price level. Similarly, on the rest of the marginal cost curve, you'll have different price points, and joining that gives you this as the supply curve. And the industry supply curve would just be the sum of all individual firm supply curves. Okay, and so on an industry level, the economic profits in the long run are minimized, are zero. But in the short run, individual firms can either have losses, have a zero profit, or have a positive profit, as shown in the three cases. But in the long run, so we saw in the short run, the firm produces as long as the price is above the average variable cost, because you want to at least cover the price of your variable cost, your variable inputs. But in the long run, since the firms are able to enter and exit the market, the economic profits are zero. So let's say if in the industry, the current firms are earning profits, then that would attract new firms in the long run. And once new firms enter the market, the new firms would shift the supply curve to the right, because you increase the industry supply, and that would push down the price up until the point where there are no profits anymore and there's no incentive to enter the market, and therefore your economic profits are zero. Similarly, when there are losses in the industry, firms start to leave the industry in the long run, and the supply curve shifts, the industry supply curve shifts to the left, and that increases the point up until there's no incentive to leave anymore, and the economic profits are zero. So for combining both of these cases shows that in the long run equilibrium, the economic profits will always be zero for a perfectly competitive market. Yeah, that's just the way of showing what I said in words. And yeah, so again, long run equilibrium is at the point where there are no losses or profits, and everyone is maximizing profits, and each firm is functioning at the minimum of their long range average cost curve. So there are no economic profits. Okay, let's move on to chapter 10. Let's say we have a single price. So now we look at a monopoly market. So let's say we have a single price monopolist. The formulas remain the same, but since the demand curve that a monopolist faces is downward sloping, because a monopolist is not a price taker anymore, it's the price maker. The monopoly dictates what the price goes in the market. So the marginal revenue is not constant anymore and is not equal to the price. So for monopoly, we get a marginal revenue curve that's lower than the demand curve, and we know demand curve is just the average revenue curve. And the reason for that is, think of a normal demand curve for any good that we have. If I want to increase the quantity of the goods I sell, I have to reduce the price on all units. So let's say I move from 50 units to 70 units. Then I'm not just reducing the price for the 20 units. I'm reducing the price for all 70 units from, let's say, 5 to 3. So that means that that decrease in all the units needs to be compensated by even a lower marginal revenue. And that's why the marginal revenue keeps on falling down and down and down, and is below the demand curve, which is the average revenue curve. So these are the curves that a monopolist faces. Let's look at how profit maximization works in the short run. We saw that for firms in the short run, profit maximization happens when MC is equal to MR, because then we've exploited all possible profits from producing an additional unit. And if you look on the graph on the right, you'll see that since marginal revenue is lower than the average revenue, you actually have profits. And the profits are just as we saw. So the average cost the price minus the average cost times the quantity you produce. Or you can again think of it as taking the bigger rectangle, which is total revenue, and subtracting the smaller rectangle, which are the total costs, and getting the shaded region as the profits. But in this case, there's actually a deadweight loss. So because since the MC is a supply, the actual supply curve, the equilibrium and the efficient outcome should be where the supply intersects the demand, right? So where the marginal cost intersects the average revenue. So somewhere between P and AC, right here. But since that's not happening, and we produce that MR equals to MC, which is the supply curve, we have this deadweight loss. So monopoly actually has a lower output than perfect competition, or the competition in general, and a price higher than the competitive market, because we're not producing at the equilibrium price anymore. We're producing at MR equals to MC, because a monopoly wants to maximize profits. And therefore, the market is inefficient because we have a deadweight loss. We lose some of the surplus in the economy. Yeah, that's all about this. For monopoly profits to keep on persisting in the long run, entry of new firms is prevented. This could be a natural barrier or an artificial barrier. Some barriers are created by governments, for example, patent laws. Some industries are by nature a barrier because they require, let's say, a heavy capital investment or an institutional structure behind it. So there are barriers in monopoly, basically. And then we look at cartels, and that's a specific form of monopoly. So when a limited group of firms actually collude together to form a monopoly. One of the most common examples is the OPEC oil, which if you've heard of the OPEC oil crisis. But yeah, when a group of firms come together and form a monopoly, that's called a cartel. And if there are too many firms that enter the cartels market, then the cartels, like monopoly power, basically goes away. Then we come to the topic of price discrimination, which basically says that if monopolies are able to segment their markets based on certain characteristics, then they might be able to get higher profits or charge different prices from each of these segments in order to make the economy more efficient. There are different types of price discriminations. You can discriminate based on the number of units of the output. You can discriminate based on market segments and so on. also based on elasticity. So the consequence of price discrimination is, again, it'll always give the firm higher profits, because now you are extracting a higher potential from each of these specific segments. And a monopoly that price discriminates will produce an output that's higher than a monopoly that doesn't price discriminate. So it reduces the deadweight loss. Yeah. Okay, so that was all about monopoly. Now let's move on to monopolistic competition, which is more of a real life setting for most economies. So you have differentiated products. Each firm has access to the same technology. No firm has a direct effect on other firms. So that part comes from the perfect competition again. But we have differentiated products here, and there are no barriers to entry or exit. So in the short run, a monopolistically competitive market maximizes profits like a monopoly. So each firm individually, in the short run, can maximize profits by functioning at a level MR equal to MC. However, in the long run, the profits become zero because of freedom of entry and exit. And as we saw, when there are profits, firms enter, and the supply curve shifts to the right, pushing the price down until there are no economic profits. So similarly, here in the long run, due to entry and exit, we have economic profits is zero. Yeah, so again, this is just the difference between short run and long run. Here, the firm was earning profits, but in the long run, we look at the long run average cost curve, and the supply curve also shifts because more firms enter, and that's why you get no economic profits. Now let's look at oligopolies. So an oligopoly is a set of limited firms, not many, limited firms. So let's say like it could be 2 or more firms, could be 3, 4, 5, as long as they're limited firms, limited number of firms, where the actions of a firm directly affects other firms in the industry. So few big players. And firms can either maximize joint profits or compete. And to understand what actually happens, we use game theory at the very basic level. So let's say you have firm A and firm B. If they cooperate, they have half of the market, so they get a 20 million profit each. If one cooperates but the other decides to compete, the competing firm gets a higher profit. And then if both decide to compete, then both firms get a lower profit, which is 17 million. So what is Nash equilibrium? So Nash equilibrium is basically each player's optimal strategy considering the other players' strategies. And a Nash equilibrium is an equilibrium such that deviating from that strategy will not make you any better, nor the other person. So how do we find Nash equilibrium? Actually, drawing would be easy. Okay. So let's look at firm A's decisions. So let's say firm B for now. So if we take actions of the other firms as given. So let's say if firm B decides to cooperate, then what's the best thing for firm A to do? So out of 20 and 22 million, since 22 is better, it's better for firm A to compete. Now, if firm B chooses to compete, then let's see which is the best option for firm A. It's again competing. Similarly, now let's look at firm B's decision. So if firm A decides to cooperate, then firm B's best choice out of 20 and 22 million would be 22. So firm B decides to compete. And similarly here, if firm A decides to compete, then again, firm B's decision would also be to compete because 17 is better than 15 million. So you see, irrespective of what the other firm does, it's always better for each firm to compete. So your Nash equilibrium would be both firms competing. They produce a joint higher level of output, but a lower amount of joint profits. So this is the Nash equilibrium. Okay, and now let's quickly finish chapter 12. So now we finally talk about efficiency. And we look at two types of efficiency. We have productive efficiency and allocative efficiency. Productive efficiency is, so let's look at a firm. So a firm is productively efficient when it's producing its output at the lowest cost. So you have basically optimized your costs. You're producing the output at the lowest level of cost. So as a firm, you've optimized and you're productively efficient. For the industry, that means that the marginal cost of production must be the same for each firm. So each firm should be facing the same marginal cost structure, so the same supply curve. And allocative efficiency is when market price is equal to the marginal cost, and we'll see why that's the case graphically. Yeah, and this is just if a particular type of market is productively and allocatively efficient or not. Okay, so now let's look at consumer surplus. So when market price is, so remember again, so the supply curve is just the marginal cost. In an equilibrium such as this, which is a perfectly competitive market, we maximize consumer and producer surplus, and the price P0 at the equilibrium is equal to the marginal cost. So it because it's the intersection of supply and demand. So the price at the equilibrium is what the marginal cost is at the equilibrium. So this is allocatively efficient. This is an allocatively efficient situation. However, when it comes to monopoly or a monopolistic setting, where your marginal revenue is lower than the average revenue, so any setting where marginal revenue is lower than the average revenue, and you try to maximize profits by functioning on MR equals to MC, so at QM, right here, we know that we create a deadweight loss. And that deadweight loss is this purple shaded area, which is area 3 and 5. Your consumer surplus is area 1, and your producer surplus is the sum of areas 2 and 4. So this is an inefficient market. Now, let's see what happens when we opt for a marginal cost pricing method. Price is set where the market demand curve and market cost curve intersect. So again, supply equals demand. And we know that the outcome is allocatively efficient. And this is for monopolies. We are just trying to solve the issue of a deadweight loss here. And we look at the long run because we want it to be efficient from long run perspective. And we see that if we go for marginal cost pricing, the outcome is allocatively efficient because you are functioning at price equals to MC. So that's allocatively efficient, but the monopoly suffers losses. However, if we opt for average cost pricing, where the price is set to be the intersection of the demand curve and the average cost instead, there are no losses or no profits. So the firm has no profits or losses. The firm produces at the level of output at which the costs, the demand curve is intersecting the long run average cost curve. but the outcome is not allocatively efficient because the price at this point is higher than the marginal cost. But the firm breaks even at point P2. Yeah, so that was everything from chapter 1 to 12. Best of luck for your exams. If you have any questions about the review session, feel free to shoot me a message on Facebook or just email me. Yeah.
Thank you very much.
Yeah, no worries.